In a world of claims, only proof gives meaning. The machinery of truth, realized as a system, verifiable by design. Trust made obsolete, designed for integrity, built with precision. This is Ziren. Hello, everyone. Welcome to this ZKM space. I'm Alice from ZKM. We are joined here with Ming, who is co-founder and chief scientist of ZKM, and Stefan, who is the CTO. So just as some context, ZKM recently underwent a branding update of its ZKVM from ZKMIPS to Ziren. So we'll be going into details of what this rebrand means, how it ties into what ZKM is building towards, and what kinds of new updates there are for developers. So I wanted to first start off with the question, maybe both, it's a question for both you, Ming, and Stefan. What led ZKM to rebrand from ZKMIPS to Ziren?
The name Ziren comes from Greek mythology, Siren, S-I-Z-E-N. And we switched the S with a Z to mean ZK. So basically, Ziren has the origin in Greek mythology, and this is mysterious. I think we'll capture a little bit about what people's impression cryptography and zero knowledge proof. But that being said, we want to completely taking off the veil and make it a technology that's universal. So this is the story behind the rebranding of Ziren.
Got it. So it actually came from the term siren.
Yes,
And you wanted
Ziren.
to capture the qualities of it being mysterious, and then also wanted to emphasize that at least the ZK part is universal for everyone. So it has some of those mythological origins to the name.
Yes. Yes, because yeah. Also behind ZKM, we have roots in Metis. That's the project implementing optimistic rollup, which is the also part of the verified computing paradigm, and the Metis project. The name is also taken from Greek mythology and also Canadian native Indian tribe name. So yeah, we want to keep that tradition, as ZKM had its roots in Metis, and also it's a completed circle that Metis implemented optimistic rollup for Ethereum, and ZKM implemented the technology that can enable ZK rollup, which are all part of the grand Ethereum verified computing quest.
Got it. Yeah, it's very interesting to hear that. Also, Metis had its roots with its name within mythology as well. So very good to hear that the tradition is kept going. And on your side, Stefan, I'm curious to hear more about some of the technical updates that comes with Ziren. So compared to the ZK MIPS version 1.1 release, which was the most recent release before the Ziren update, I'm wondering if you can talk about some of the new improvements that were made with Ziren with this new release compared to the version 1.1.
Yeah. Okay. Yeah. Basically, we this release is 1.1. So the previous release is 1.0, and so yeah. So in the release 1.1, actually, we have several. Um, we have several significant improvements. Including the first is the prover. We implemented the end-to-end GPU prover. So once end-to-end GPU prover, first, as we know, when we want to prove some our general proof for some real world use case, we not only generate the proof for its native computation, we also need to aggregate all those proofs and compress the proof to make sure the on-chain verification cost is few. So, so the end-to-end GPU proof means we enable the GPU acceleration for the uh, block proof, and also for the aggregation proof, and also for the proof stack to snack proof conversion. So yeah, so this and for the GPU acceleration, actually the performance improvements is very impressive. Um, we achieved 30 times faster for the core proof. Also, we see this block proof, and then we achieved 15 times faster for the proof aggregation, and 30 um, um, times faster for the proof wrapping. And the second improvement is the instruction efficiency. We added some new complex instruction like the multi-add, multi-sub. So this kind of complex instruction is combined the multiplication and addition together, and this kind of instruction can reduce the sequence size uh, for the prover. So eventually it can improve the proof generation efficiency. So we define the instruction efficiency to how many instructions we generate for a guest program. So that means if we can take a look at this proof, the Ziren cycles or instructions. Yeah, we can consider one cycle, one instruction. So we can check out that Ziren's cycles is about 10% less than the RISC-V based ZKVM. Okay, and the third improvement is the pre-compares and the pre-compares. I think we add we already support about 40 pre-compares in our ZKVM right now, include the field operation, group operation, large number operations, and the some and the ECDSA signature verification. And we also support we also support some wide used guest program. That's the IETH for Ethereum mainnet, and the IETH for God network. And the last improvement, I think, is the tool chain upgrade. So we already launched our GPU powered proof network. It should be like the test nets. Not everyone can access right now, but we will open it in the next few months. So on this proof network, we can just submit the program, the guest program, and the provers you want to use, and then you can get the proof after the proof generation done. So so basically that's all there's for large improvements. Yeah. So of course we also have some other upgrade in this version. More detail can be checked out in our Doc's website, doc.zkm.io.
Okay, so there's a couple of new improvements. So one relating to, as you mentioned, GPU acceleration. There's around a 30 times speed up in terms of generating the core proof and also for proof wrapping. And then also you mentioned that there's a couple of opcodes that were added, like the multi-add and sub, which also increases the efficiency for the proof generation. And in addition to that, just as a recap, there are more precompiles that were added, as well as more upgrades for the toolchain. Okay, got it. So quite a few different upgrades there, and altogether, I think those really contribute to the proving times, the reduced proving times that we see. So that's great to hear. And Ming, on your end, I'm wondering, with this name change, it's not just kind of a rebrand that comes from the team, but I'm wondering if there's a broader narrative or some sort of broader vision that Ziren captures beyond just the technical upgrade as a ZKVM. So with Ziren, what does it encompass in terms of its narrative or vision beyond just being a ZKVM?
Yes. So the name rebranding is our effort to push the ZKVM technology to the mainstream because, as you know, ZKVM or anything ZK related, and also in general, like cryptography as the foundation for the blockchain technology is, let's be honest, a bit like mystique, and also also very hard to understand from a traditional IT point of view, even for people in the field, right? Let alone the general public. So why do you need this? It's kind of similar to the beginning of Bitcoin. So people wondering what this is. It's because it's something you cannot touch. There's something that it's based on math. So it took a long time for Bitcoin to be mainstream, and even that there's not much application for Bitcoin itself, just as a alternative asset. And we want to change that for the technology we're developing. This is also something plaguing the whole blockchain, or some call it Web3 movement, because the application is very transaction based, like finance and transaction based. It's hard to develop the general purpose apps that permits all aspects of our life. There are ways to incorporate blockchain and Web3 technology in it. But the point of it is that it provides something new, right? If you just redo everything that's already there in Web3, then you need to give people a reason, right? I think the reason is not just it's more secure, because security itself, as we know it, it's always like surpassed by convenience. So it's time and again, users would choose convenience over security. So security alone doesn't really cut it. And before blockchain and also ZKP, secure apps are just around for a long time, and it never standalone. So it found its place in business applications, but in general public, it's just a small niche market. But our vision of ZKM is that universal verifiable computing is going to be a new, bigger use scenario than just the security apps, or the ones that you can sort of use crypto, right? So the whole field of crypto, if it's just being a kind of finance app, division of ZKM to push to the broader application space, because Web3 as it stands now, in general, the blockchain applications are quite limited to finance applications, right? So in that case, we would naturally see like hundreds of different kind of wallets, and obviously we don't want that. We want a very diverse application space. So the vision that we're pushing is actually broader than finance apps, even decentralized finance apps, cryptos, and all that. The vision we're trying to build is called universal verifiable computing, where you can generate proofs for any application trace, basically making any computing verifiable. And what that means is that you can turn any compute sequence into a decentralized part of a decentralized application. So we all know that crypto, for example, Bitcoin, is decentralized in the sense that it will use verifiable computing in its own special way to prove that their computing results are trustworthy. So it's called trustless trust. Usually they use very different, diverse ways to achieve that. For example, Bitcoin uses proof of work and also to vet its computing and its transactions, everything. So different blockchains use different ways to make it decentralized. So basically, to achieve a decentralization, you need verifiable computing. It's just the way that ZKVM enables is universal. So not just blockchain apps, not some special crypto use cases. It's universal, meaning any piece of computing can be made verifiable. That's decentralized. Of course, you also need incentives. That's the part that Bitcoin pioneered to also, be able to achieve other characteristics of a decentralized application. For example, liveness, right? So, so this is a very broad vision, and the foundation of it, we think, is to be able to generate proofs for any computation. And this is what ZKM does. The ZKVM we developed, it's called used to call ZKMIPS, and this rebranding of Ziren is the foundational technology we built for this verifiable computing future, where you can make any application, the new ones, to be verifiable and decentralized. And this will open up a new kind of applications beyond what people call Web 2 and Web 3. So this is a much bigger space, and we're very excited about it.
Got it. So you see ZK as encompassing use cases that are even larger than what's present in the Web 2 and Web 3 space. Like you mentioned before that we were originally more restricted to these financial or transaction-based applications. And it was really hard to build more general purpose ones. And in terms of just the security application, you mentioned that users tend to choose convenience
over security. Yes,
over security. So in terms of just using security on the user side, there wasn't really too much of a demand there. Perhaps on the B2B end there was, but just on the main user side there wasn't as big of a demand. But now we have this new paradigm for universal verifiable computation as sort of a larger use case compared to security. And I see it really intersecting with, as you mentioned, not just in crypto, not just in Web 2, but say in like verifiable AI, which I know that you are working very closely with as well. There's a lot of other ZK projects who are looking into that space as well, where ZK can be applied to the verifiable AI space. And there's also plenty of other applications as well. So really great that you mentioned the need for ZK for these general purpose applications, not just for those that are, say, crypto based or those that we see in traditional Web 2. So thank you, Ming. And Stefan, on your side, Ziren is also contributing to ETH proofs, and wanted to hear some of the developments that are made towards real-time proving and towards the ETH proofs initiative. So, for example, one of the updates on the Ziren side relating to real-time proving, I believe the block state prep time was reduced from 5 minutes to just around 30 seconds. So in addition to this development, very curious to hear some of the technical challenges that the team had to go through and where we are in terms of this path towards real-time proving. What else needs to be done before we can achieve it?
Yeah, we say the yeah, as we know, if we want to achieve the real-time proving, we not only accelerate the prover itself, we also need to speed up uh, the inputs preparation time. Yeah, I would say it's input preparation because this is not actually included in the proving time, which means it's only in this step in this preparation we only download the block data and in which consists of the account states, uh, transaction block. Yeah. So basically, it's not a very big challenge to speed up the speed up the preparation phase because we yeah, for us actually we before this before 1.1 we basically use we are proving the EVM, and we also need to prepare the very specific account status like the slots for the smart contracts account, the um, the account state for of course the account state should be for all the accounts including the UA and the smart contracts accounts, and also we need to yeah, but when we want to download or prepare all those kind of data, we need to use some Web3 RPC like the get like the debug get trace get transaction trace oh sorry, this should be cut. Yeah, when we prepare for this kind of data we actually need to use some Web3 RPC, especially the debug debug category the RPC in the debug category. So if we have like hundreds even 500s of transaction in a block, we need maybe in work this kind of RPC for many times, yeah, like 500 times. So that means we actually need execute the RPC between the get the host the Ziren host program and the RPC node for about 500 times. So it's quite slow. But when we upgrade to IETH, actually from the from proving the EVM to from the to proving the IETH, we basically use another RPC to prepare for the data that's the prover need. So it takes about less 30 seconds, but it's not the I mean it's not the state of the art because we can see that Zk call just needs about 3 seconds. That means we actually the another version of the then not another release from the IETH. It means stateless IETH stateless. In this release, we have another RPC. It's debug get execution witness. So it can help us prepare the data directly, and we just need to use one remote call to get the data, to get the witness data, and then we can begin to prove. So yeah, so this maybe this is very important because if we want to achieve the real-time proving, that means we need to prove 99.9% of the blocks in 12 seconds. We need to limit the prepare time to less than 3 seconds, maybe 2 seconds or 1 second. So yeah, so this is very important for the real-time proving. And yeah, of course, we will upgrade to this new RPC. Yeah, in next 2 weeks. Okay, so yeah, so back to real-time proving. We still have a lot of yeah. I believe we have everything on track. First, we compressed the prepare time. We also have the improved GPU approval right now. And one thing I want to say that before we achieve the real-time proving for Ethereum mainnet, actually we already achieved the real-time proving for God network. And for the God network, actually the block time is much shorter. It's about 3.4 seconds. We already achieved that. That means we can apply this mechanism to Ethereum mainnet, but with more machines, more GPUs. Yeah. So basically, we still yeah, this is the framework to realize the real-time proving. And in terms of the GPU acceleration, I think we still have some space to exploit. We are still analyze the bottlenecks to make sure they proving faster and faster. Yeah. So yeah, I think that's we still on track, and we achieved some big milestone in terms of the real time proving for any layer 2 or any blockchain. Yeah.
Yeah, sounds great. So it seems like the kind of two main bottlenecks that the team has been working on is one, the need to speed up the inputs preparation time.
Yeah.
So, for example, from downloading the block data to getting the account states and so on. And then the other bottleneck that you've seen was how you had to invoke the RPC node many times if there were, say, you gave the example of 500 transactions per block. So you need to execute the RPC between the host program in Ziren and the RPC node itself around 500 times if that were the case, if that were 500 transactions per block. But now there's that ability to have one call to get that witness data before proving. And it's very impressive also that you mentioned that real-time proving with Ziren is actually already achieved on Goat's end.
Yeah.
And you mentioned that on Goat's end, that time is a lot shorter, around 3.4 seconds, and that the team can now apply this framework to Ethereum mainnet. So there are some bottlenecks to still address, but lots of improvements have been made.
Yes. Exactly.
Okay, got it. Okay, that sounds very exciting, and yeah, I think the team is very close on that end. And going back to you, Ming, on that use case for enabling Ziren to expand not just for security, not just for Web 2 or crypto related use cases, but to enable for universal verifiable computation. I'm very curious to hear any specific types of use cases or uses that you see Ziren optimized for in this universal verifiable compute use case. Any types of applications that you hope for developers to build with Ziren?
Yes, let me go into a bit depth I mean by universal verified computing. I mentioned, of course, I emphasize this new kind of non-financial decentralized application that will use verified computing as the basis foundation. But first, let's go back to the Web3 space because I think a lot of our audience is interested in ZKM because of this. Actually, before we will expand into this new unexplored, uncharted space of non-financial decentralized applications. We can actually make our existing Web3 space applications much better. Basically, we can reunite or let's say refactor or rebuild every Web3 blockchain crypto application again with ZKVM technology and make it faster, cheaper, more secure, and easy to develop, and also easy to deploy. So I think that's probably what we'll start with, and also achieve certain applications that's just impossible using older technologies, for example, non-ZK or non-ZKVM technologies. I would mention that we have already built in parallel a Bitcoin, well, we call it Bitcoin layer 2, but it's basically enable Bitcoin's general computing capability. So we literally expanded Bitcoin with a more universal computing capability. This wasn't possible before because, as I said, the limitation of this older technology is that it's fixed. The consensus, the capability of the blockchain slash crypto is fixed at its inception. So you wouldn't be able to expand because unlike traditional application, the consensus mechanism is fixed. So in order to do this, it's a big surgery. For example, we all remember in the history of Bitcoin, you had this big war for even increase the limit of the block size. Anyways, and upgrade and any improvement took in the Bitcoin universe took years to implement, let alone to expand its capability, right? What we mean by expand is not just for like hard fork or soft fork. It's a fundamental capability that's not in the original design of Bitcoin. So this sounds improbable, impossible, and but with ZKVM, with Ziren, we're able to do it, and we're the first together because there are many claim that, but with compromises, sometimes even on the level of scams. We're the first to do it, to actually build strictly within Bitcoin's consensus. So we have violated no Bitcoin consensus rules. All the expansion, all the new capabilities are verified on the Bitcoin main chain as part of the Bitcoin consensus itself. So this is only possible with the power of our ZKVM Ziren. And build on that, we can even say we can rebuild all the existing Web3 applications to make it truly decentralized. Because, for example, a big application is exchanges. Exchanges mostly are centralized, and we can rebuild them into fully decentralized applications. We can also rebuild even existing blockchains that are not capable. We can give them the capabilities that it doesn't have. Anyway, so I give examples in the Web 2 space. You heard of a lot of things to rebuild this and that, like ZK email, or ZK this, ZK that. But the truth is, we could make things better, more improved using this technology. But the more exciting applications with the ones that never existed before. For example, in ZKM, built with the first what we call Gold network for Bitcoin general purpose computing, and we would be able to do this again for other blockchains, as I mentioned earlier, and this is called entangled rollup. Basically, we would expand the concept of ZK rollup to beyond Ethereum, to other blockchains, and this is enabled by Ziren, the ZKVM, but also with the power of zero knowledge proof virtual machines to achieve something that's never been done before, which is a secure unified liquidity. Basically, we can make what we call native assets, cross-chain native assets possible in a very secure and aligned with the base blockchain consensus, which has never been done before, because traditionally it was done by bridges, and bridges are very insecure. They're basically a hotbed for scams. But with entangled rollup, with zero knowledge proofs and universal computing, this is possible. We can achieve cross-chain native liquidity in a secure and consensus aligned way. So this is very exciting, and I hope that we have more applications that never even existed before. For example, in gaming, right? We never had like a decentralized gaming, meaning that users control everything. You're part of the universe, the gaming universe, not part of like a server that's owned and managed by the developers. And you can be kicked out. You don't have permission to co-create. But in the new decentralized gaming world, because of unified, like a universal computing, this verified computing, this is all possible. So the limit is only the developer's imagination. So true decentralized applications will see a renaissance beyond the original finance apps, and probably many apps we haven't even imagined now will be created. So I'm very excited to see that future unroll before us on the foundation of what we built here: Ziren, ZKVM, and universal verified computing that they enabled.
Great. So we can expect kind of like a new series of applications to be enabled in addition to enhancing, for example, existing like Web3 applications, say when it comes to being faster, with being cheaper, with being more secure.
Right, and more diverse. Yes.
More diverse as well.
Yeah. Mm-hmm.
And in ZKM's case, right now with GOAT, ZKM can really help enable or expand Bitcoin's general computation capability while not violating any sort of consensus rules involved. And then tying it into the larger vision for entangled rollup, really enabling cross-chain native liquidity for like EVM compatible chains, and perhaps even like in the future non-EVM.
Well, not just EVM, because we're
not EVM in the future.
We're beyond EVM. We're general purpose. So Ziren can support any instruction set, any machine, existed, non-existed. Yeah. Mm-hmm. Instead of like this EVM, we can also support ROS. We can support other, for example, other blockchain using other script engines, virtual machines. Yeah, mm-hmm. not just limited to EVM.
Right.
We even support like just traditional CPU programs, right? On the blockchain. So.
Right. So right now, like for example, with GOAT, we are EVM compatible, but in the future, we can anticipate being compatible with other ecosystems like MVM or SVM, so on. for that to enable that cross-chain native liquidity. Okay, yeah, that makes sense. Thank you, Ming. And Stefan, on your side, I wanted to go back to some points you made about some of the new pre-compiles. You mentioned quite a few new pre-compiles that are available for developers, and now there's currently a suite of around 40, between 40 to 50 that are now available. So I'm curious to hear, how does the usage compare between each of them, and if you could give an example on an application that can be accelerated with the use of a specific precompile.
Yeah, we already have 40 pre-compiles in Ziren right now, and all the pre-compiles can be checked out in our websites, doc websites. So yeah, so all those kind of pre-compiles can allow the developers to speed up their calculations, like the large number computation, especially the field operation or being 254 or group operations, or the signature verification, yeah, or yeah, similar large number computation. So if of course, if we want to I have we are focused right now on very important um of course, we also have have a lot of hash, pre-compiles. An example recently we focus on is the verification of the Gabber circuits for God network. Not only for God network, but for Bilvim 3, because there are some new improvements from the Bilvim Alliance. So they propose the Bilvim 3, which is Gab circuit based, and before the governor actually commits the input and output labels on the Bitcoin, the governor also need to prove that the entire circuit is generated correctly. So the governor need to generate proof for the entire computation. But in that, in actually a circuit consists of maybe billions of gates. In each gate, a label is random or is a secret key, and we also we have two like for example for AND table. We have two inputs and one outputs, and the outputs label is calculated from the hash of the input label and output label. So that means we actually, if a circuit consists of like 1 billion gates, we actually have about 1 billion hash in that. So for so many hashes computation, we need to choose the most efficient one and most efficient hash function, like the Poseidon 2. But you can check out that most of ZKVMs implement Poseidon 2 inside of the ZKVM, but not expose this kind of hash function to the user space. So that's what we are doing right now in Ziren. And of course, if you want to enable this kind of pre-compile in your guest program, it's very simple. We just need to replace or patch the crates you're using. Take SHA-2 for example. You may use SHA-2 in your guest program, and you import the SHA-2 crates from the officer wrapper. Now, if you want to change it to our pre-compile, we also fork the SHA-2 wrapper to our Ziren patch organization in GitHub, and then you just add some patch in your cargo TLML, your guest cargo TLML, and replace the and patch it with our SHA-2 implementation. Then you can enable your SHA-2 on our pre-compares, and we also have a lot of benchmark in our issues. If you want to check out it before you really replace in your crates. And of course, when we talk about the pre-compares, I think it's not the end game that we have 40. We are saying 40 is not enough. It's usually it's maybe case by case. If you have some new programs, like for example, let's go back to the gap sockets. We can not only provide you the Poseidon 2 precompilers, we can also provide the gate leveled precompilers. That means we can allow you to speed up your gate operation directly by precompile. So we will add more precompilers in the future if developers want to have more optimization on the guest program. We also welcome the developers to contribute their pre-compares to our ZKVM. Yeah.
Okay, sounds great. So it sounds like, at least for example, with the jarbled circuits that are enabled with BitVM3, there are some precompiles such as Poseidon 2 and some other kinds that can speed up the operations when it comes to the gates. Just because, like for the garbled circuits, you mentioned that it could, for example, consist of a billion gates in a single circuit. Okay, that sounds good, and very exciting to see the types of specific accelerations that can be made via different cryptographic operations. So really good that you're providing this whole suite of precompiles, and based on kind of the needs for the developer, if they have a specific operation that they want to accelerate, they can very easily just use the patch crates and implement that in their cargo file instead of just implementing those precompiles directly using external system calls. So it sounds like the developer team at ZKM not only is implementing more precompiles, but also making that developer experience in terms of integrating them a lot more streamlined. Yeah, sounds good. And if someone, say, wanted to create a Ziren-based rollup tomorrow, what would that deployment path look like? Can other Bitcoin-based ZK rollups be integrated with Ziren in addition to Go?
Yeah, I think we have a lot of things to say about that, because we are building more like end-to-end solution for Bitcoin ZK rollup. We're not only building the prover for the state transition functions like the EVM for the Bitcoin layer 2. We also build the web file verification or web file Bitcoin based web file for so basically in Bitcoin ZK rollup, the verifier side is more sophisticated than the prover. I think somehow we can say it like that, because most of the team, we can see that most of the team, like Citria, AirPnaps, they just focusing on the proof verification. They don't really spend much effort on the proof side. They maybe use some other ZKVMs, but for Ziren or for ZKM, actually we have everything in house. Now, so basically, if we want to build a ZK rollup for Bitcoin, we have multiple layers, like the execution layers, consensus layers, relay layers, and verification layers. Of course, we need to prove the execution layer and consensus layer on Bitcoin. And then we also need to implement, or we also need to enable the Bitcoin to verify the proof. Yeah, for those kind of layers, we all need to interact with the KVMs or proof network, because we can see that the proof can be used to represent any computation off chain. Still, this basically for the consensus layer of the execution layer. When we implement the verification layer, we still need the KVM. Just for example, we are improving the BitVM2 protocol by BitVM3. BitVM3 is a gap socket based solution. As we mentioned, that we need to prove that the socket is generated correctly. So we need to use, so we can there are a lot of optimization to implement malicious or some adversary assumption based gap sockets. Like some maybe use the current tools, some use the type tree based, like the BitVM3S proposed by Robin Linus. It's type tree based. But for us, we are collaborating with the God network to exploit just proving the entire circuit directly by Ziren. So this also, of course, why we want to exploit this kind of solution, because it's more comprehensive, and it's when I say comprehensive, because we can use the proof directly to proving that the circuit is correct without any additional storage overhead, communication overhead. We just convert the storage for both on-chain and off-chain to proving overhead. So that's one we are able, or we are good at. So back to this kind of back to the proof-based BitVM3 solution. It's also helpful for the all the BitVM2 based zk apps. Okay, so we talked about the execution layer, consensus layer, and the verification layer. Best if you want to build a zk app for Bitcoin, I think you can reference. I'm not saying you are needed to do everything as God network or some other Bitcoin layer do. You can always reference to the design of our proof generation for those kind of layers. So I think it's not really challenging to take a reference of those designs, but in the further step, I would say if we really launch a real-world zk app for Bitcoin, security is the first things we need to consider. Another things we need to consider is the efficiency. That's as I also mentioned, we already achieved the real-time proving for God network. So if you really want to improve the capital efficiency of the operators of the challenges, you also need to implement the real-time proving. For example, if you cannot implement the real-time proving for your network, for your rollup chain, you cannot enable the operator to kick off his reimbursements in time, and the time will be the delay or the lag will be accumulated. That is, you may need a few days or few weeks, even few months to finish your to finish your reimbursements or withdraw from the from your rollup chain to the Bitcoin. Yeah, so I think real-time proving is also very important for your Bitcoin rollup. Yeah, that's all I have in mind right now. Yeah.
Got it. So ZKM is compatible with some other ZK-based Bitcoin rollups, and they can always reference to the design of Goat, but doesn't necessarily have to replicate all the components. It's just that we should be intentional about kind of first the different layers involved within the ZK rollup, such as with the execution, with the consensus, relaying, and verification layers where the where proofs can be generated for each. And in terms of the priorities, you mentioned security, efficiency, and also the ability for real-time proof generation for that specific Bitcoin layer 2.
Yeah, I think the verification layer is more general. So actually, it can be used for every Bitcoin ZK rollup, and not only for ZK rollup, but can also be used for any off-chain computation verification on Bitcoin. Like if you are building some state channel for Bitcoin, you can also use the like Bitcoin 3 and Ziren to implement your on-chain verification. Yeah, it's more general. Yeah.
Got it. More general purpose, more flexible.
Yes.
Got it. Okay, well, thank you both. Great to hear from Ming the origins of Ziren and also the different kinds of use cases for universal verifiable compute. And from Stefan, really great to hear all of the developments made on the technical fronts, like with the precompiles, like the strides towards real-time proving, and then also some of the details involving the integration process with Bitcoin-based ZK rollups. So very great to hear from both of the sides, and also very exciting to see how much ZKM has really done in the past couple of months, and very much looking forward to what's next in the coming months. So thank you both.
Thank you, Alice.
In a world of claims, only proof gives meaning. The machinery of truth, realized as a system, verifiable by design. Trust made obsolete. Designed for integrity, built with precision. This is Ziren.